To have water that is potable, that means that it is safe to drink. So if it contains impurities, the impurities, if it's going to be safe to drink, must therefore be harmless to the people drinking it. So that's the only one that makes sense in that way. Wastewater can be used to produce drinking water. The process includes these three stages, so sedimentation, filtration, and chlorination. What is the sedimentation process? This is where we let things settle out to the bottom. So the only one, we get the impurities to settle out to the bottom of the container. State why the water is filtered. So we filter water to remove any kind of insoluble substance. So remove insoluble substances. And the reason we chlorinate is to kill bacteria. So whenever you get a graph presented to you, it's really important that we reuse the information in the graph in our response to the question. So we can see here we are given two bits of data. We've got the amount of salt that's been added and then the percentage of impurities that are being removed. And the question is looking at two different types of salt. And we can see if we look at salt A, we see salt A is this line here. So salt A is increasing in terms of the amount of salt added. The amount of impurities being removed is increasing until we get to this point. And that point is at 150 milligrams of salt. And that's our maximum amount of impurities being removed. And we can do the same for B. B's got this increase here. And then you've got peak here at 100. And then it starts to decrease again. So the question wants us to say A or B, which is best. It's suggesting that the best way to purify the water is adding B. So if you have a quick look at this, if we look at, there's two different answers to this, and either answer is okay. So I've got answer 1, answer 2. Answer 1, I'm actually arguing that A is better because if we look at A, if we get to 150 milligrams, we're actually removing more impurity than B is removing here. So 150 milligrams of A removes more impurity, and therefore A is a better salt to use. That's what we've got here. You can also argue that B is better because B removes more. If you use 100 milligrams of B, it removes more than 100 milligrams of A. So in terms of equal amounts, B is better, removes more impurities, and therefore less of B is required to remove the impurities from the water. As I said, either answer is okay, but you have to argue it and present the evidence to support your argument. Okay, so in this equation, or this question, sorry, we've been asked to react aluminium ions with the phosphate. So we've got the phosphate there. Aluminium ions, if you look at aluminium on the periodic table, it's in group 3 and therefore forms a 3+ ion. We've now got to work out the formula for aluminium phosphate. So if I just go over here to show you how to do that. So aluminium ions are 3+, and therefore they want to make 3 bonds. Phosphate ions are 3-, and therefore they also want to make 3 bonds. Cross them over, but before we cross, we can simplify to 1 to 1. So aluminium gets number 1, the phosphate is PO4, and it also gets a number 1 coming across towards it. So the formula is AlPO4 for aluminium.